everyone, this is Module 2B, Example 1 on page 34 in your packet. So remember to read through your vocabulary first to familiarize yourself with the new vocabulary for Module 2B. Example 1 is about El Nino, which is the periodic warming of the Pacific Ocean. And El Nino affects the monsoon rains that are essential for agriculture in India and other Asian countries. So our list here are monsoon rains measured in millimeters for the 23 strong El Nino years between 1871 and 2004. So question A is asking what is the minimum monsoon rain in this list and what is the maximum monsoon rain in this list. So one way to do this is to type the data in Excel and sort. So let me show you how you could do it that way. Over here in Excel, I have already typed in the data list, so you can go ahead and download this from Desire to Learn under Data Files, or you could type it out yourself in Excel. And then to sort, we highlight all of our columns. So in this case, we're A1 through A23, all of our cells. And then if we go to Data, over on the left side we have Sort, and depending on which version of Excel you're using, it may be in a different spot, but it's all there. And then we want to go from smallest to largest, so that's what's called ascending order. And here we go. We can see here in cell A1, the smallest data is 604 millimeters, and if we scroll all the way down to A23, our largest data is 957 millimeters. Okay, so here we want to type in that our minimum monsoon is 604 millimeters. And the maximum monsoon is 957 millimeters. The other way you could have done this is just by inspecting the table. If you look here, you can go through and find 604, the smallest, and 957, the largest. So our next thing to think about is what would be good bin sizes to make a histogram. So when we set up our histogram, we want something so that the bins are evenly spaced, and we want to avoid what we call pancakes, where the data is stretched too much and you get flats. And we want to avoid skyscrapers, where too much data is crunched together and you get a lot of peaks. So I think counting by 50s would be good. You could also count by 20s or 40s. 100 might be a little too squished. So we're going to list our bin sizes, starting at 600 and listing by 50s. And we want to go all the way up to 1,000 so that we include the 957. Technically, we don't need 600 because the bin is the upper cutoff, so you could omit that and just start at 650. Because our lowest value, 604, is more than 600, so it would fall into the 650 bin. So now we're going to use Excel to make a histogram. Remember, if you're using the PC version of Excel, you want to list the bin sizes over in column B. If you're on a Mac, like me, you can go into Tools and use Better Histogram if you've downloaded that add-on. So our data range is A1 through A23. And then we want to start our histogram, we set at 600, and we want to count by 50s, and we want to stop at 1,000. Then I'm going to click OK. And where's my histogram? And here's our histogram. So we can see here now the shape. So it looks like it is close to what we call symmetric. It looks like the center is between 750 and 800. And it looks like there's a little bit of a tail out here to the right. So let's go back to our packet and make those notes. And you guys can put a sketch of the histogram here in part C, or copy and paste your graph in here, or make a printout of your graph. So we said the histogram is mostly symmetric, has a peak between 750 and 800 millimeters, and has a tail to the right. And we can go back to the list of data and count. We know from the Excel that there were 23 data points. And then part F we actually already did. It's asking us to use Excel to reorder column A in numerical order and then figure out which number falls in the middle. So if we go back to Excel, back to sheet 1, when you make a histogram, it'll open a new sheet down here at the bottom. So your data is always back in the sheet where you started with it. And here's our 23 data points. So the middle must be what? If we had 11 data points, that would be 22 total if 11 was the half. So the 12th data point must be right here in the middle. So let's double check. There are 11 data points above and 11 data points below. So our middle number, which we call the median, is 784 millimeters. So we can say here, 784 millimeters falls in the middle of the data. And so this number is what we call the median, and we use this notation capital M to represent the median or this word midpoint. So you can call it the midpoint or the median. And you'll hear both terms used. So we'll put our 784 millimeters right here. Example 2, we're continuing to find the median. And here it's giving us a list of 16 flower lengths measured in, well, it doesn't tell us the units, but so it does tell us it's rounded to the nearest tenths. I'm assuming it must be in millimeters. Back over to Excel, and this data is over here in sheet 2 to go with example 2. And I've already typed it in, so you can download this file or type it in yourself. And then to make our stem plot, remember it's helpful to reorder it. So I'm going to sort it in ascending order. And so the tenths column is going to be our leaf, and our whole numbers are going to be the stem. So it looks like we should start with 46 and just count by ones all the way up to 50. So our first stem will be 46, then 47, then 48, then 49, then 50. So for 46, when we come to look at the leaves, we have 3 in the tenths place, 4 in the tenths place, so we want to start to list these as our leaves. 6 in the tenths place, 7 in the tenths place, and then 2 8s and a 9. And if you want to go ahead and label that the leaf is the tenths place, so you don't forget, that might be helpful. Now 47, we've got a 1 1 and a 4. And remember, every entry in the leaf represents a data point, and that's what helps us see how tall the bars would be if we want to imagine that this is like a bar chart. 48 just has 48, which is actually 48.0, 48.1, 48.3, and 48.4. There are no entries with measurements 49, and then for 50 we have 50.1 and 50.3. So this is our stem and leaf plot. You could sketch this in your activity packet in the space provided. If you want to type it in Excel and make a printout for yourself, that's fine also. So we go back to our activity packet. So you would sketch your stem plot here. And now we want to think about what's the shape of our stem plot. So if we look back, if you imagine turning it sideways, there's an early peak, and then it looks like the tail goes to the right side. So we can say this stem plot has a right tail. And remember, you're visually rotating the stem plot. There is an early peak at 46, and then the data trails off to the right. So now it wants us to think about which two data points lie in the center. So if we count up the total number of data points, we know that there are 16 data points. So the two middle points would be 8 and 9, right? Because those would both have 7 values below them. So it's by coincidence that they're both 47.1. And so we would take the average to find the median when there's 2 data points in the middle. And the reason why there are 2 data points in the center is we have, in this case, an even number of data points in this set. So anytime you have an even number of data points, you're going to have anytime you have an even number of data points, you're going to have 2 values in the center. And when we find the median, we take the average of that. So part E is telling us when there are 2 data points in the center, the median is midway in between. Find the median by adding together the 2 data points in the center and dividing by 2. So in this case, we can add up 47.1 plus 47.1 and then divide by 2. And this one we can do in our head because it's the same number. We know that the median will be 47.1. And then it wants us to label the median in the stem plot with an arrow. So you can go ahead and label that in your drawing or printout.